Hi, and welcome to Teaching Tip Tuesday, brought to you by the Center for Inclusive Teaching and Learning at UWSP. Although faculty tend to agree that a college education isn't simply job training, students attend college with the hope of gaining the knowledge, skills, and dispositions that will qualify them for a well-paying career. It's therefore no surprise that the Association of American Colleges and Universities routinely polls employers about what skills and dispositions they think are important to the success of their workforce. Over the next 2 weeks, I'll discuss how we might consider the career preparation aspect of college in the generative artificial intelligence era. I'll begin this week by discussing how GAI capabilities may impact the valuation of knowledge and skills associated with Bloom's cognitive taxonomy. GAI performs some functions better than humans are able to, and the expectation is that as development and training of large language models continues, they'll only get better. As they do, only graduates who have knowledge and skills that make them better at tasks than GAI is alone will have real value to employers. Therefore, it will be important that instructors re-evaluate the learning goals they're setting for students. Most educators are familiar with Bloom's cognitive taxonomy, which categorizes the complexity of learning and of actions that demonstrate learning. We use this taxonomy as a way to present learning goals or outcomes in a student-centered framework that highlights specific actions or tasks that we'll use to measure student achievement. For college degrees to maintain their value in the age of GAI, college grads, either alone or in conjunction with GAI, will have to be able to exceed the performance of GAI alone. So it's important that instructors know GAI's capabilities with regard to the different levels of learning represented in Bloom's taxonomy, and how each level of learning will be relevant for our students in the future. Let's begin with the lowest level, involving recall. Remember, this level of Bloom's taxonomy is associated with the ability to recall informational details, whether it be to list components or options, define terms, or sequence events. GAI does this very well. It's limited only by the data that are used to train it. Because large language models have access to huge amounts of data, they can quickly recall a seemingly endless array of facts and figures. The main shortcomings to GAI in completing the tasks associated with this level of the taxonomy are that GAI output will reflect any inaccuracies or biases that are present in the training material, and that there is a potential for hallucination or pure fabrication of information, especially for information not included in the training data. Although GAI may surpass humans at remembering, there's a strong case for continued emphasis on humans gaining basic knowledge at this level. Only with expertise and recall of their own can people fact-check or recognize biases in GAI output. Also, if students are to understand most disciplines, they must internalize the basic concepts and definitions, as it would be impractical to engage in higher-order tasks without having fundamental knowledge. In this regard, GAI may be thought of as a crutch. It can help with walking, but it can't replace legs. Understand. This level of Bloom's taxonomy is associated with comprehension of informational details. It allows one to produce an explanation, interpretation, summary, example, illustration, or translation. GAI can do very well at some tasks associated with this level of Bloom's taxonomy, but it doesn't understand anything as humans would conceive of understanding. GAI can recognize and replicate patterns in the training data, but as with tasks associated with recall, GAI is limited by shortcomings in the training data and in its inability to distinguish moral or contextual nuance. Humans have greater ability to contextualize understanding and attach emotional, moral, and ethical components to that understanding. Because understanding is foundational to other levels in Bloom's taxonomical hierarchy, this level of learning is still valuable in many disciplines. Application. This level of Bloom's taxonomy is associated with using knowledge and understanding in novel situations. It inherently involves problem solving, recognition of when, where, why, and how to employ methods and ideas, and demonstrating the use of concepts in real-world scenarios. GAI tools that are trained with specific processes and procedures can apply them to new data, provided that the context and parameters of the application are sufficiently similar to the training data. This means that applications performed by GAI require data and predictability. AI is not good at intuitive leaps or engaging in creative problem solving, so it may be able to engage in applications that are very similar to those for which it was trained, but unable to modify in light of differences in context or detail. Humans are much more adept at solving unfamiliar problems. We can recognize when to apply specific methods and ideas, and when those methods or ideas are not working or are insufficient for a given problem. Being able to solve complex problems that do not conform to training parameters is a more uniquely human skill. Analysis. In Bloom's taxonomy, analysis involves understanding the structure of knowledge. It requires breaking complex material into components to reveal patterns and structures. Analysis involves critical thinking to examine what is known from different perspectives, distinguish between facts and opinions, and to reveal relationships. GAI tools are really good at analysis, since they can examine extraordinarily large sets of data at speed and integrate or compare different sets of data. They're able to automate this and to identify patterns and trends rapidly, as well as to answer specific questions about the body of the data. They aren't that good at determining what questions to ask. Humans will never be as good as AI at analytic functions, but we are better able to combine nuances in our real understanding than GAI, which lacks both real understanding and doesn't process nuances as we do. This allows people to identify relevant questions to ask about data that GAI cannot ask itself. We can also bring unique emotional and moral dimensions to our analysis. We're able to integrate internalized values from the affective domain of Bloom's taxonomy when examining the structure of knowledge. Evaluation. In evaluation, one applies criteria to judge the value or appropriateness of anything that can be analyzed. It requires ethics, judgment, and contextualized understanding. GAI does not do well at evaluation, since it's not good with ethics or understanding. Although it can produce something that sounds authoritative, it's limited to replicating forms that are present in the training data. It doesn't evaluate well those things that it was not trained on. It can't actually interpret the value of things, just as it can't technically understand concepts. Humans have the distinct ability to combine context, ethics, and affective values with analysis, allowing them to critique, justify, and evaluate authentic problems and potential responses. These judgments are important in evaluating the work of GAI in all contexts. Create. In this level of Bloom's taxonomy, the expectation is to put various components together to produce a new and unique functioning whole. Creating is generative and necessarily draws upon all the knowledge, understanding, and skills that people, or GAI, have acquired through their experience. GAI can be highly creative because it has at its disposal a vast array of possible components to put together. It can rapidly generate a series of choices or possible organizations. However, it is limited by patterns and trends that are present in data. Just as it can't solve novel problems that don't fit previously observed parameters, it cannot make an intuitive leap or juxtapose elements that aren't found together in patterns that it's already seen, unless it's provided with a prompt instructing it to do so. And because it doesn't understand, it can make mistakes in what is essential to any given pattern. Witness, for example, how GAI image generators try to make human hands. You can end up with any number of fingers, any number of hand bodies. They usually look ridiculous. GAI lacks the judgment to alter these kinds of mistakes. As with GAI, humans' abilities to create are related to their training data and existing knowledge. We don't generate something from nothing. Instead, we see ways to repurpose, reuse, slightly change those things that we know. But unlike generative artificial intelligence, we have the ability to apply judgment in creation, so our creations are rarely wrong the way that GAI creations can be. Based on what humans will be called upon to do in the era of GAI, as you consider the learning goals for your courses, remember the following. Knowledge and understanding will remain foundational, so don't give up yet on holding students accountable for mastery of content. Students' ability to apply knowledge and understanding should focus on novel contexts as much as possible, since that way they will be able to do what GAI can't. Although it's likely that analysis of knowledge will be carried out by GAI, our graduates will need to know what kinds of questions to ask about knowledge. Evaluation will maintain its importance because GAI is just not good at it. And finally, to be more creative than generative artificial intelligence, which can only reshuffle the deck, our students will have to mint new cards. They'll have to be adept at thinking outside of the box and juxtaposing elements in a way that hasn't been seen before. To ensure the relevance of a college education in the era of GAI, now is a great time for instructors to re-evaluate their learning objectives in their courses and to lean into the skills that are uniquely human. Tune in next week when I'll frame this in the context of career preparation by covering the top 10 skills that employers want from college graduates, modified slightly to account for the influence of generative artificial intelligence. And that's this week's teaching tip, brought to you by the Center for Inclusive Teaching and Learning here at UWSP. Remember, at CITL, we offer support for course design, learning activities, assessment, and pedagogy. Visit our website to schedule a consultation today.